Sea level rise in Miami, a coastal city of significant economic importance, has been an ongoing issue since the early 19th century when European settlers began establishing communities along Florida's Atlantic coast. The phenomenon stems from global warming and its direct impact on polar ice caps melting, contributing to ocean volume expansion as well. This gradual process was initially slow, but accelerated significantly with the onset of rapid climate change in the late 20th century. Miami became particularly vulnerable due to its low elevation relative to sea level, averaging just a few feet above it, and extensive coastal construction that has exacerbated flooding events. The first notable rise occurred between the mid-19th and early 20th centuries, with an annual average increase of around 3 millimeters per year. However, this pace quickened considerably in the latter half of the 20th century to approximately 5 millimeters annually by 1980. By the mid-21st century, the rate had escalated further, reaching about 6.7 millimeters per annum, with projections indicating it might reach up to 13.4 millimeters by 2050. The most severe impacts manifested in increased flooding frequency and severity during high tides and storm surges, leading to widespread property damage and disruption of critical infrastructure, such as transportation networks and power stations. Economic repercussions have been significant, with Miami experiencing annual losses due to flooding estimated at over $60 by 2019. Socially, residents are facing more frequent displacement issues, necessitating the construction of seawalls, drainage systems, and flood barriers designed to mitigate the effects. In terms of environmental consequences, increased water temperatures have led to coral bleaching events causing the loss of up to 50% of corals in local reefs by 2030. This degradation not only affects tourism but also disrupts marine ecosystems vital for biodiversity and food security. On a positive note, innovative policies like green roofs, stormwater management systems, and climate-resilient architectural designs have been implemented to reduce vulnerability. Looking ahead towards the year 2050, projected sea level rise is expected to exacerbate current trends, resulting in even more substantial economic losses, estimated at around $1 billion annually. To address these challenges, cities need to adopt a multifaceted approach involving stringent emission reduction targets, extensive adaptation measures, and public-private partnerships focused on resilient urban planning strategies that prioritize the protection of low-lying areas against rising waters.